let's go ahead and find an equation of this hyperbola described above. We know that its foci are at 3, 0 and negative 3, 0. So the first thing I usually do is draw a picture. So those are my foci. Now it says that the transverse axis length is equal to 4. The transverse axis is always going to be in the same line that goes through both foci. And the transverse axis connects the two vertices. And so I'm just going to put a vertex here and a vertex here. And since that has a length equal to 4, and this hyperbola is symmetric, as are all of them, then I know that this must be 2, 0, and this must be negative 2, 0, which tells me that that my a value, right, because that's the vertex will always have coordinates a, 0 and negative a, 0 if the foci are situated like this. That means my a is equal to 2. And I also know that the general structure of my hyperbola should start with an x squared as opposed to a y squared. So since a is 2, I know that there's a 4 right there. Now I just got to find my b value. And that's where the identity comes into play. So I know that a squared is equal to b squared plus c squared in hyperbola. And that means that 4 is equal to b squared plus, now c squared is 3 squared because c is the distance between the origin and either focus, so that must be 9, which means that b squared is 5, which means that b is the square root of 5. And so b squared would give us the value that should be below that y squared there. All right. Just quickly while we're at it, we can find the asymptotes. And, I don't have a great grid here, but we can try anyway. In order to sketch a good picture of this hyperbola, you'll want to draw a rectangle whose sides are parallel to those axes, the transverse and the conjugate axes. And we know this clearly has a width of 4, and since b is root 5, then this distance is 2 root 5. But more importantly, this is poorly drawn, but I'm just going to make a really thick origin there. The asymptotes go through the origin, and with this rectangle you can always recover information about the slope, because this rise, so there's my b value is root 5, so that must have coordinates 0, root 5, that value there, and that must have coordinates 0, negative root 5, which tells me that the slope of this line here is just going from origin to that top right corner of that rectangle. The rise is root 5 and the run is 2. So there's one there's one asymptote, and the other one would be, again, starting from the origin going down root 5 and right 2. Would have those equations. Alright, in the actual hyperbola, this diagram's getting a little crazy, but the actual hyperbola would have this general shape. Alright, so we've got our equation. For a bonus, we got the equation of the asymptotes. And again, don't forget this identity. It turns out to be useful. Let's say we had to find the equation of a hyperbola with a transverse axis that has endpoints -2, -2, and -2, 8. And the slope of one asymptote is 5/3. We also have to find the foci. So again, a picture is our friend. let's draw in these points -2, -2, and -2, 8. Now, since the transverse axis connects those 2 points, those must be the vertices. So I might as well just call those the vertices. Now, to find the center, which is going to help me find the equation, I just got to go halfway in between those vertices. So you can do that one of 2 ways. You can sort of count actual intervals, count actual units to find the halfway point, but you could also just take the average of the y-coordinates. So -2 plus 8 is 6, divided by 2 is 3. So 3 is going to be where the y-coordinate of my center is. But again, notice the distance from either side is is 5 in that case. Counting up 5 from the center in both directions. So now I know that my center is equal to -2, 3. Now I know that my hyperbola is going to be opening up and down as opposed to left to right, because the transverse axis is vertical. So that means that if I'm getting my equation set up, it's going to start with the y squared term. Now there's a shift, so I'm just going to leave a space here. And the shift is indicated because the center is not at the origin like it is for the standard equation. So let's talk about that shift. The shift is, well, the center is at -2, 3, so that's a shift of left 2 and up 3. So left 2 shift and up 3 would look like that. And my A term is just this distance here, which is 5. So that means that this is a 25. The A term will always be, the A squared term will always be under the first, first squared term here in this expression. Okay, now to find the b value, I think I'm going to use the info that we haven't used so far, which is that the slope of one of the asymptotes is 5/3. So the asymptote will go through the center here. So I can't sketch it yet because I think we need to kind of get this rectangle sorted out. So the rectangle will have sides that go through the vertices. So we know the rise. So the rise is going to be 5. I'm just going to use red here. The rise is going to be 5, right? And according to this, the run should be 3. So if I move over 3, that brings me to here. So here's one asymptote, and going in the same direction here. If the rise is 5/3, then going down, I have to go down 5 and then left 3. And that defines the other sides of my rectangle. So one asymptote goes like that. And because we know that half the length of each rectangle is A and half the width is B, in this case, this must be B. In other words, B must be 3. So that must be a 9 here. Okay, so that rectangle really gave us our B value. Now, it also asks us to find the foci, and that's when I think we're going to go back to that Pythagorean identity, which is that a squared plus b squared equals c squared. So a squared is 25, b squared is 9, and c squared is what we're trying to find. So that means that c is the square root of 34. Now, c is the distance from the center to either focus. So if my center is at -2, 3, then the focus, one of the foci, is going to be -2, 3 plus root 34. Now root 34 is, in between 5 and 6. So it should be right up here. So it's going to be up here beyond the vertex. And the other one's going to be right here below the vertex. And I'll get that from taking the y-coordinate and minusing the square root of 34. All right, and again, remember in this case, in an ellipse, the foci are before the vertices if you're traveling from the origin to either one of them. But in this case, the case of a hyperbola, the foci are beyond the vertices. Okay, and so yet another description of a hyperbola whose equation we were interested in, and using the symmetry of the hyperbola as well as our knowledge of shifts and that Pythagorean identity allows us to find all the info we need.